this is supposed to help you with section 14.4. It's on the normal distribution. So the first thing that I wanted to do was just to show you some pictures and explain what's going on a little bit. So the first thing we're going to look at, well, let me write 14.4 up here. So if we look at this normal distribution, this is the normal bell curve, okay? When we look at all of this shaded area underneath the curve, all of this, okay, what percentage is underneath there? All the way in these tails and everything, that's 100%. The whole thing under the curve, all of those data values would be 100%. Now, what if we do this and we draw a picture like this, where we put the mean? Remember, the mean is right in the middle. So the mean divides it in half. So if we're looking at this shaded area, what does that represent? Well, that's 50%. Half is in there, okay? Then we have the rule that divides it up using standard deviations. So maybe before I do that, though, let's also say that this side, I don't want to make you believe that just one side. So if we put, say that that's the mean. So say that this is the mean. Okay, so what's this part here? This would also be 50% that's on that side. So this line here always is dividing the graph in half. Okay, now we have the rule that says 68, 95, 99.7 rule. Okay, so basically what it says is if you divvy it up like this, okay, so here's your mean. If you go one standard deviation in both directions, okay, so we're going to say this part here, that's 68%. Okay, so this would be the mean here. This would be plus one standard deviation, that's minus one standard deviation. That's 68%. So, because this line is in the middle, what does that mean for this then? If we have the mean here and we just go up one standard deviation, what's that going to be? Well, what percent does that have to be? Well, that has to be 68 over 2%, or 34%. Hopefully that makes sense. If this whole thing is 68, what is half of it? 34. Well, it really doesn't matter which way we go here, if we go to the left or to the right. So if we have the mean here, and we go this way and subtract one standard deviation, and we talk about this area in here, it's still 34%. It's still 68 divided by 2, or 34%. Okay? So now you have other questions relating to this. You might have a question that asks you, well, we're not interested in what's within the one standard deviation. What's outside of that? So let's start again with this picture. So let's actually have a problem where we say, let's say the mean, let's call it problem number 1. The mean is, sorry about that, I'm kind of in the wrong place. The mean is 50 and standard deviation is 10. Okay, so remember what you're supposed to do. You draw this picture. Okay, you put the mean right here, 50. And then you go 1, 2, 3. You divide it up into fairly equal pieces. And then you move in terms of standard deviations. So you go, add 10 here would be 60, add 10 more 70, add 10 more 80. And then when you go down, you're going to subtract. So 50 minus 10 is 40. Minus 10 would be 30. Minus 10 would be 20. So what can we say now? We can say that if we looked at data, whatever this represents, okay, we would say that 99.7% would be between 20 and 80. That's within 3 standard deviations, okay? What about within 2? So between 30 and 70, 2 this way, 2 that way. That's 95 because the rule says within 2 is 95. And then within 1 would be 68%, between 40 and 60. Okay, so let's ask that question. So part A, what percent of the data is between 40 and 60? Okay, so we're going to draw our picture here. Draw it a little smaller here. So we're going to go like this. Put the mean right here, and then we count out 1, 2. Whoops, I kind of was a little shy there. 1, 2, 3. It's okay. You're just trying to get the picture across. Okay, so between 40 and 60. So this shaded area right here. Okay, that is within 1 standard deviation. What we mean by that is we went up 1 standard deviation, we went down 1 standard deviation. So we know the rule tells us that's 68%. Okay, so now let me ask you a question. What is the unshaded part of the graph? Suppose I ask you what was between, below 40 and above 60. Well, if this part is 68, what's left over for the other part? Well, if we say 100 minus 68, isn't that 32? So we have 32% left over for the 2 tails, okay, which the tails here are pretty big. The unshaded area would be 32. But because this divides it in half, the mean divides it in half, this piece here is equal to this piece here, okay? So let's color it in a different color. Let's say that the yellow part, okay, so the yellow part equals the shaded yellow part. Okay, but then because we said that it's symmetric about this mean, we know that half of that 32 has to be here and half of that 32 has to be here. So 32 divided by 2% or 16% is in each tail. So we know that 16% is here and 16% is here. So how do we know that we've done it right? Add it up. Got my calculator here we can use. Okay, so we're going to take 16 plus 68 plus 16. What do we get? 100. So underneath the curve is 100%. Okay, so if we were asked in part B, let's say we're asked, what percent of the data is, let's say, above 60? What's the answer to that? Well, we can see that's the shaded yellow part, 16%. Let's answer part C. We'll say, what percent of the data is below 40? Well, that's 16% too. That's this shaded yellow part. Okay, let's answer part D. What percent of the data is either below 40 or above 60? Well, we see that it's the 16 and the 16. So it's 32%. Okay? So what you can do, it might make it easiest if you just start labeling the different shaded areas of the graph and then figure out what the problem is asking you. So I want to answer now, let's see, what is part E, what percent of the data is between 50 and 60? So can you answer that question? Well, we know this shaded pink area is 68%, right? But that's between 40 and 60. If we just want 50 and 60, doesn't that have to be half or 34? So we'll say 68 divided by 2% or 34%. Okay, let's answer another question. And I think I'll draw the picture again here. What if I want to know what percent of the data, is less than 60? Okay, so let's draw a little picture for ourselves here. So here's our 50, and then remember we go 60, 70, 80, and then we go 40, 30, 20. Okay, so we want to know what's below 60. So I'm going to shade this in two pieces. I'm going to shade this part pink, and I'm going to shade this part orange. Okay, so let's see if you can tell me what that's going to be. This part here, we just answered this question of what's between 50 and 60 above here. What was between 50 and 60? Well, we determined that it was 34%, half of this total pink shaded area. So that was 68 divided by 2 equals 34%, okay, is in that pink area. What's in the orange area? Well, let's think about that. You could do it two different ways. You can look at this picture up above here and say, well, it's the pink and the yellow together, which let's try that out. We know it's the yellow, 16, plus the pink, which is 34, which gives us 50. Or you can say it's half of the curve, half underneath the curve. That mean divides it in half, so that's 50%. So it can be done either way. So now if you want everything below 60, what do you have to do? You have to take all of the orange and all of the pink and add it together. So you're saying 50 plus 34. 50 plus 34 equals what? 84%. I should put the little percent signs on here. Okay? So that's one question. What if I ask you in part G, what percent of the data is above 60? Oops, just 60, not percent, the number 60. Okay, so now let's take a look at the picture here. So again, 50, 60, 70, 80, and 40, 30, 20. Okay, so now what are we shading? We want to know above 60. Okay, so above 60, I'm going to shade that in yellow. I think I already had that answer. We already had that. But let me show you another way to do it. Okay, if we hadn't already figured that out, there's different ways to do it. I have it labeled up there, but let me show you another way. Couldn't we say that this is equal to the whole curve minus what's below that? So we'll say like here's 50, here's 60. You should just be able to play with these numbers, and you always know that, you know, it has to add to 100. So if you're looking for, let's go with a different color. Okay, so this, you know what? I'm going to do it this way again. I'm going to do it because of the problem we have above. I'm going to say pink, and I'm going to say orange. Okay, and we'll say the whole thing is green. Okay, so this piece right here, we're trying to figure it out. Well, I don't want to look like I'm missing any part there. This is 100%. The whole thing is 100%. If we subtract off the white piece here that's missing, what was this equal to? Well, this part was 50 because it's half. This part was 34. We've calculated that over and over. So we've got to subtract that. So we're saying 100% minus that was 84%. What is that equal to? Well, if you do that on the calculator, 100 minus 84 is 16. Isn't that what we said this was before? 16. So there's many different ways to do these problems. You just have to draw the picture, shade, and figure out what pieces you have. Okay, I'm going to do another video with a little bit harder problems, but hopefully this helped you with the more basic ones.